Bismillahirrahmanirrahim. Dear viewers, today we will continue our manual building load calculation. In the previous tutorial, I have shown how to get the frame UDL for the whole building. Now from that frame UDL, we will calculate the axial load for columns so that we can get the reaction value. So let's start. We will start with grid 1. Here the grid 1, so grid 1A. We will start with this column. Okay, here A to B. In this column, see here only two beam, right side and upper side, bottom and left side no beam. So we will make this 0. Here upper side and lower side span length UTL 0. So upper side span length, slab span width same like this one. Because column is still not finalized, so we cannot deduct the column length like this one. We cannot do. We will take full of the slab width or slab span same like this one, 4 meter. Here we will take the column size like this one. If we delete this one, so we can consider this full length from here to here 4 meter. If the design come from this size, for example column, so this additional length of the column will be adjusted from the concrete unit weight from column. Okay, so we'll consider this 4 meter span. If we consider this is not calculated, we will write it later. 4 meter upper side span length 4 meter, and this side, right side span length is 6 meter. 6 meter. Okay, this Excel sheet I will share in the description box. You can get the link there. Now watch carefully. 6 meter. So A to B, this A to B, it is 20.25. 20.25. For upper side 1 to 2, this direction along 1 to 2 number grid in grid A. So we'll check in grid A. Here is grid A 1 to 2. This is 17. Okay, UDL is 17. So this is the load from beam total. See here, full span length is 4. So half of the span will be shared to this column. For example, this half, and this side, this half. This half of the span load will go to this column, and this side half span load will go to this column, and this side similarly this half portion load will go to this column. Okay, so we have taken half of the span into the linear load 17 kilonewton per meter. If we multiply this one, then we will get 34 kilonewton. In the same way, right side 60.75 kilonewton. Okay, so this is here the load from floor, all four side it is adding. So as there is two side and this is 0, so summation is coming 94.75. The column size we will take this 20 centimeter by 20 centimeter. This 20. Okay, and the height of the floor, as this is roof, so the total roof is 3.4 meter for 3 floors. That means roof floor height also 3.4 meter. 3.4 meter. Okay, so column self weight, it is coming 3.4 kilonewton. So total this and this will become as 98.2 kilonewton. So this one I will copy here as number. Okay, so this done. Roof 2, and if there is n number of floor, so roof 2 lower floor, that means n minus 1 number floor, it will, this is the load 98.2. now come to next floor. This one, grade 1, right side, this is roof. Now 3f 25.66. okay, right side 25.66. span will be same, and this side 1 to 2, grid A 1 to 2, this is 22.42. 22.42. okay, so this is the floor load and column self weight, this one. So total load 125.2. copy and paste here as value. Okay, here axial load will be automatically shown in the diagram, and here we are adding these floor loads to get the axial load diagram. This one at top floor, this is the load. At this floor, this is added with this load plus this load, so total 223.4. next will be this plus this. okay, so this one we will calculate now. This done. Now go to this floor. As it is a typical 3 floor, so this and these 3 floor will be same. okay, so we can copy this one, copy 1 2 and this number 3, this 3 floor same, so we have got this 3 same value. Now come to the plain beam or grade beam level. So here it is, upper side grid A 1 to 2 10.82. okay, so go here, upper side 10.82, and here for grid A to B in grid 1 10.82 same, so 10.82 point 10.82. okay, so this is the load. So load from coming from floor, ground floor 54.1, column self height this one, ground floor height 3.6 meter, so 57.7 it is coming. You can copy this one and paste as number. okay, so up to this we have got our value 57.7. this load, this 1.6 meter. okay, we can check here, this is 0 and this one 0. we'll calculate the column size. For example, here we can take a larger column, for example 50, as it is going down below the plain beam and height is 1.6. self weight 4, so total load 4. So this is going to plain beam to foundation level. This is 4 kilonewton. We can type here 4, and here in this case, as our floor is up to this, we can make them 0, others are 0. Okay, so this is our axial load diagram, and here in the axial load diagram we can remove the data which is having 0 load, or for this building we don't have these floors, so we will remove this data. So select this diagram, go to here chart tool, and here select data. This is the chart data. We will select this one, then from here to here this one, then enter. Okay, click OK. So this is our axial load diagram for our column 1A. This is 1A. 1A coming by this grid 1A. So this is our axial load diagram, and our reaction load is 535.5 kilonewton. Okay, so this column we have got, and similarly I am showing for one internal column, this one middle column. Let's check, this is 2B. This copy, create a copy. Here I'll write the name 2B. This is the column axial load for 2B grid, this one. Now here we will check in this, for this column we have 4 beam or 4 span for 4 side. So we will write the span length first, 5 this side 5, 6, 4, and this 4, downside 4, 5, 4, 6, 4. This is 5, this is 4 downside, and this side 6 meter, and this side 4 meter for that column. And now we will check UDL A to B, B to C for grid 2. Grid 2 A to B, this is 33.16 and 24.33. 34.16 and this side 24.33. Okay, and now at grid B, 2 to 3, 1 to 2 and 2 to 3. So go to grid B, 1 to 2 and 2 to 3. 1 to 2 it is 23.67, that means bottom 23.67, and upper one 2 to 3, this is 30.38. So this is the column for side beam. This is the load, total load coming to 74.43, and this provide 3.4 meter up to roof. So column size is 20 by 20. We will take column cell for this one. Total, it is the total load for the from the roof to 3rd floor, from the roof to 3rd floor. So we'll copy this one and we'll put here like just number, paste as number. This one we will no full, no fill. Then for marking this done. Now the second one, as it is grid 2, is typical for 43.91, 43.91, and this side 35.08. and here this side, this span, this one 1 to 2, 34.42, 42, and this one 2 to 3, upper side 2 to 3, it is 41.13, 41.13. Okay, so this is the load from floor and this column sulfide, so 377.0. Copy this one, paste as number. Okay, this done. As there is 3 typical floors, so copy this one, 1 2 3, done. Now for the clean beam, we know this one all 10.82, this side, as there is no floor load, only wall load, 10.82 for grade beam level, linear load 10.82, 10.82, 10.82, 10.82, and this one 10.82. So total load coming 102.79, and this ground floor height 3.6 meter. So column self height 3.6 kilonewton, and total load coming, self height coming from concrete unit at 25, and the column height, width and length. So this volume and unit weight, this is for making centimeter to meter, making centimeters into meter, converting for conversion. So this is the self weight for column 3.6 kilonewton, total load. This one we'll copy, this one, and here we'll put as value. And clean beam to foundation, this is 1.4. this, and here we can increase the size for column. Self weight, because we are taking only self weight for from clean beam to foundation, so we can take the higher column section. This is 4.2, this 4.2 will write here 4.2. So this is our loadings, floor wise column load, and here the axial load. At the bottom it is coming the reaction load. So this is the axial load diagram for column 2B. We can see the value here like this. So this is our axial load diagram, and this is 1519.3. we can write 1520 here. We can write 1520 for reaction, 1520 kilonewton for this interior column, for this interior column or middle column. In this way we can calculate all the reaction load for the rest of the columns, and we can get the axial load diagram like this. Okay, So in the similar way, we have calculated reaction loads for other column supports. So this is our all reaction loads, and here in the Excel sheet we have got the axial load diagram. Here all the columns I have calculated. So in the beginning we have calculated slab load, then we have added wall load with beam self weight, then we are calculating the axial load for columns, and from the axial load diagram we are getting the reaction loads, and that reaction load we are writing here in the drawing. So in this way manually we can calculate the reaction loads for a full building. So we can review our steps. We can draw the load distribution diagram for a building floor, then we can check the span, then we can get the load coming from floor to beam, then the load distribution for beam from two sides we have added here to get the total load coming from floor to beam, then floor load plus wall plus beam self weight, wall load plus beam self weight load added with this load, then coming this floor load. This is for roof floor, this is for typical floor, and this is for grade beam or plain beam level. Here no slab, only loads coming from wall. From it we have got this frame UTL for all the frames of the building. From here we have got the reaction load and axial load diagram with the help of Excel sheet. So in this way we can calculate the floor loads, frame UTL and reaction load and axial load diagram manually. So thanks for watching. Stay tuned for more upcoming tutorials.
Press the bell icon on the YouTube app and never miss another update.